They are single-celled green algae that grow in fresh water, and you can find them pretty much across the globe. This microorganism is so cute, but it's much more than a pretty face. If we apply a little stress to Chlamys, this species can do amazing things for us. For example, producing the lipids and sugars that we can use to make biofuels like biodiesel and ethanol. Sugars and lipids, particularly lipids, can be easily extracted from Shlamydomonas culture, as you can see in this video. This is a promising green alternative for producing biofuels. Why do we need an alternative? Many biofuels today are produced from crops like corn, massive amounts of corn, which is driving up the cost of food worldwide. Ethanol and diesel produced from Chlamys don't compete with people for food. As a bonus, cultivation of Chlamys is very cheap and doesn't require any complex equipment. But producing biofuels isn't all that Chlamys can do. It can also make hydrogen, which can be used in engines and for electricity production. While growing, it produces biomass that can be used in conventional heating systems. And on top of that, it's helping to solve climate change by pulling carbon dioxide from the atmosphere. It's easy to stress Chlamys so that it produces the products we want. One way is to just remove nutrients from the growth chamber. Here, for example, you can see two Chlamys cultures, a normal one and one without nitrogen. The second one, the stressed one, is producing a lot of lipids that we can use. But why is it that a stressed out Chlamys gives us things we can use? Well, when Chlamys notices a decrease in the nutrients around it, it starts eating as much as it can, producing lipids to prepare for the hard times ahead. This is great for us because we want the lipids that Shlamydomonas can produce. And here's another stress. If we cool Chlamys down, it starts producing sugars as a kind of natural antifreeze. And we also want those sugars. But here's the problem. These kinds of stresses are very easy to do at a small scale in the lab, but they are really difficult and expensive to do at an industrial scale. This drawback is really limiting the growth of this technology. So here's the question. Can we encourage Shlamydomonas to make the things we want without having to so tightly control its growth environment? And that's where my research comes in. Understanding exactly what's going on in the Chlamys cell when it's stressed. If we can fully understand that, we might be able to engineer Chlamys cells to produce all the things we want without needing such a precise level of control over their growth environment. During my research, I found a group of genes that seem to be part of the master regulation of stress in Shlamydomonas. But I need your support for proving this hypothesis. If I can confirm that these genes are part of the stress response, we should be able to manipulate them. We should be able to engineer a new strain of Chlamys that constantly produces the lipids and sugars that we can use. If we have this new kind of Chlamys, we'll be able to increase the production and to reduce the cultivation costs, making this technology even more attractive. And here's the big thing. This technology will be free for all to use, not just kept secret in the hands of a few companies. It will be a discovery that will belong